Hey, Kiara, good morning. Hello, Timothy Peduso and Kai. Maybe some of you are morning people like me, even though I don't look it this morning. Good morning, Cassidy and Corsine. Good morning, Matthias. And good morning, Clara. And Julius and Zach, good morning. Good morning, Aslan and Ingrid. Good morning, Alessandra and Ayala. Oh, where am I? Good morning to so many of you. Nice to have you with me here on this Tuesday morning. Hello, Hannah. Hello, Sophie. That's great. Okay. Who else do I got? I got Aaron and Inessa. Good morning. That is super. And I've got Malta and Corey. Good morning. Super. Man, I got everybody. This is good this morning. And I've got Isaiah. Hello. And Sina. And I've got Avram. Good morning, Avram and Linus. Moving right along, I've got Devante and I've got Amelie. This is going to be a record today. Everybody's here. It's wonderful. I've got Liam and Anton as well. Soupy. And I've got Allie, good morning. And Michael, good morning. That's pretty super. Okay, let me read who I still need. Okay. Looking for Alessia, Stella, and Tim Hartling. Paul, I don't know if he's with us. I think he left for another school. Lauren, I need, and Charlotte. Yeah, that would be fine. Alessia, why don't you go ahead and start typing them? Type me your questions. That would be great. Yeah, that's cool. And Lauren is here. Good. That's most of 9F. Okay, 90. I'm still looking for Leo and Isaac and Jack. Also, Alicia. Isabella, I saw. Good morning, Isabella. Looking for Felix and Aaron as well. Okay, while those folks are checking in, Alessia, type me whatever questions you have, and I'll try and answer them. So, for everybody, good morning. Thanks for joining me. Here's what's up. Felix is there. Aaron, I got you already. Thank you. Felix, I got you now. Okay, just what I want to talk about. Good timing, Alessia. She says, how will the hybrid learning proceed? How long will our school days be? And which subjects will we have? Okay, far as I understand it, and it's a big if we don't have a lockdown, because the numbers are not so great in Germany right now, if we don't have a lockdown, then as I understand it, me being a humble teacher, next Monday we'll start the AB hybrid plan. Hello, Charlotte. Thank you. I sent my group already, 9F, who's in A and who's in B. So look back at your emails if you didn't see that. I've sent it to you twice, actually. And A group would start next week. And as far as I understand it, Alessia and everybody, you will have all your classes A group. Okay? You'll go like your regular schedule in your regular rooms, as far as I know. I take that back. Go to the regular room you've been in over in the B building. Okay? So what is that? 2-0 whatever for both groups. If they change their plans about that, they'll send you a schedule, Alessia. So no worries about that. And Timothy P, I got you already. Thank you, sir. So what will happen is, I think you have your regular school day, okay? A group will have it next week. B group will be learning at home still. So that's the scoop. And then the following week, B group will be in school and A group will be at home online learning. It'll be different than now, because with us teachers, we got to be in school and online teaching at the same time. We can't do it. So we'll probably give you some reading or whatever assignments on the internet, but I can't do live streams probably with you, because I'll have to be in school all the time. And there we're not supposed to have our live streams at the same time as we're doing live in-person instruction. I hope that's clear. I tried to make it clear. Stella, good morning. Will we have sport and elective classes? Alessia, I assume you will have sport and elective, but I don't know. And Leo is here. Thank you, Leo. Any other questions from anybody about how things will be next week? At least our best guess, okay? Because things can change. Keep your arms loose. You got to be flexible, right? That's the way of the world right now for us teachers, too. Any other questions about next week? Okay, I'm going to put these aside. See if some others still join us, but for right now. And for our class, let me tell you what's up. We got two things going on. I'm going to turn the camera a little bit so you can see my whiteboard. For one thing, I'm going to have we do have more questions. All right, hold on. Are we supposed to wear a certain type of mask in school? I'd wear as good as you've got, to be really blunt. I wear the NN-PA2 mask. I wear the big white medical mask. If you got that, wear it. Okay? If you don't, if you have one of the other medical masks, I think you can wear the blue ones as well. But I don't remember what they've told me. Okay? And I think on the S-Bahn, you've got to wear the FFP2 mask anyway. So you're probably going to have one, a lot of you, for the S-Bahn. So just keep it and wear it in school as well. Okay? We'll have you spread out as much as we can in the A and B different groups in your classroom. And we'll have the windows open and stuff as well. Okay? I did it yesterday. I had all my windows open. It was cold, so wear a good big jacket. But that's what we have to do, right? Okay. And another question, are we allowed to get extra homework the days we have hybrid learning? I don't know how it's going to work with homework. I know what I'm doing this week with my 10th grade. This week, 10th grade has A, B, Alessia. So I have an assignment for the students at home to work on, and I have a different assignment for the students that are at school. So I have two different homework assignments, one for A group, one for B group. I may try and do the same with ninth grade physics with E and F. Okay? So that's kind of what I'm thinking. And do we have to get a Schnell test before we go to school? I'm not sure if you need to get one every day, Alessia, or not. I'm not sure what they've decided. I thought it was going to be a couple times a week, but you know what? We'll have to look at the website for that one because that one I really don't know. But the JFKS website should have some information about that probably later in the week. Good. Any other questions from all of you? I hope to see you soon because it's funner to teach students in person, and I'm sure it's funner to learn in person. But on the other hand, we should give ourselves a little pat on the back because you've gotten through all of nuclear physics with me, and I think it went pretty well for most of you. And I think you learned a lot of stuff about nuclear physics. We're done with that now, okay? So what we're going to do is, oh, another question from Michael, I think, yeah. Um, will there be lunch break or will there only be school since it starts at 9:45? I think it only like for the 10th grade, Michael, it started at 9:45 only yesterday. I think from now on they start at 8. So I think it's going to be a regular school day, Michael, with a lunch break. But I'd bring a lunch. I don't know if the lunch counter will be open for selling you stuff or not. You may want to check the school website to answer that. So I'm not sure what to do on your lunch break, if there'll be food or not. Maybe. Okay, Allie writes, will school last the same hours? Yes, Allie, as far as I know, it'll be the same schedule as you had back in December when you were last in school. As far as I know, it's the same thing. Although, wait a minute, you guys switched an hour anyway. It'll be your normal schedule, okay? So the one that you have in your hands, hopefully. Yeah. So, Alessia, I would say check the website and see if the school lunch program will be open. If nothing else, by Friday, um, Frau Robertson will probably do the Friday news on the website, and I'll bet you they'll cover lunch. But I'm not that important. They didn't ask me about how they're going to open the lunchroom or not. So that I don't know. I'd be ready to bring a lunch if nothing else. Okay? At least that first day. But you may find out something ahead of time that I don't know. And I got Tim Star. I'm guessing that's Tim Hardling. Is that you, Tim? Better late than never. Yep. Thank you, Tim. Okay. All right. So here's what's up with our class next week. For those that'll be in school, so next week, you guys in the A team will be in school. For physics, you're going to have you guessed it, Chester, quiz later in the week. But it's not going to be on everything, okay? What I'm going to quiz you on is going to be like the homework assignment I gave you a few weeks ago. So it's going to be on balancing and identifying alpha, beta, gamma, fission, and fusion reactions. Okay? I think it'll take 20 minutes. We'll probably schedule for like whenever later in the week is for each group. Okay, so the A group, that'll be next week, towards the end of the week. We'll pick a day, all right? For the B group, it'll be the following week, okay? So B group quiz is the following week. And that's about all I got for announcements. Let's see if you got any other questions before we start up with a new topic. While you're thinking, let me go get you a couple things to show you about our new topic. Here we go. Okay. Alessandra has a question. Alessandra, let's see what's up. Okay. Oh my goodness. She says, I thought the B group would go first because the 10th grade B group starts next week. And it would make sense to keep the B's together. I'm not sure they're going to bother doing that because, frankly, Alessandra, whether you're 10A or 9A, I don't think it makes a whole lot of difference. Even if you got a brother or sister, I'm not sure it really matters much. So far as I know, this is the way it's going to go. If it is the opposite, then it's going to be the opposite. Okay. All right, Jack is here. What a wonder. Late, but at least there. Okay, so let me mark Jack. And away we go. Okay? Yeah, 10th already started, Aslan. They started this week with their A group being in school. I taught them yesterday. Exactly. So 10th started yesterday. So the A group was in. They're in all this week. 10th grade B group will be in next week. Alessandra, as far as I know, A group will be for 9th grade in next week. If I find out something else, I'll try and let you know. But in the meantime, you can look on the school website too. That info will all be there, especially the Friday roundup. And if we get locked down, all bets are off, right? Okay. So, 9th grade physics. It includes 3 topics. One of them's pretty short, and we're going to work on that now. We've done nuclear physics. We're going to start what's known as optics. What do you think? What might optics include? Can you type in a couple ideas? What do you suppose a unit on optics will have in it? Is that part of physics? I'm going to move you up a little closer too. In my 1 square meter studio. Yeah, exactly, Aslan. It'll have to do with light. Zach is right. We're going to study eyeglasses in case you wear glasses or contact lenses. Yeah, lenses, exactly right. We'll have that. Aslan as well. Something to do with the eye. Yes, Aaron, we're going to talk about eye physics. Michael, prisms, not so much, although really glasses are kind of a prism, so to speak. They bend light. Sight and lenses, exactly right. UV, no, we won't go into it that much, but glasses, right, Julius. Some properties of light. Exactly, Kiara. Light illusions. Illusions would be fun. We don't really do that, but light and vision, right, Alessia? Lenses, sight, exactly. Spectrum of light. I don't know if we'll have time for that or not, Isabella, but we'll certainly get into visible light. That's what you and I see. I don't think we'll have time to do UV or ultraviolet. Although if we do, I'll put it in because that's really cool stuff. I like talking about light. Reflections, not so much. Mainly, we're going to talk about refraction, how light interacts with matter. Yeah, specifically rays of light. Yes, Isaiah, we're going to talk about rays of light and behavior of light, mainly when it changes medium. Okay, so we're going to talk about this idea first, refraction. Refraction. Now, a lot of you had reflection. We have mirrors, right? Our light reflects off a mirror. So that's probably old stuff. This is not about reflection. Refraction has to do with, let's see if somebody wrote something. Yeah, exactly right. Caused by light. Thank you, Isabella. Exactly right, Isabella. So it's the bending of light. And let's use the word that somebody used. Was it Aslan? I can't remember now. Somebody said light rays, and I can't remember because so many of you responded. Thanks for responding. It makes it more fun for me sitting in my basement. Okay, so it's the bending of light rays when light changes medium. Oh, there's a new word. What the heck is medium? Is it like small, medium, large? No, it's not. So light changes direction when it changes medium. Okay, what do you suppose medium means when we're talking about light? Let's take some guesses. What might be the medium that we're talking about? Oh, I got maybe some, yeah, bending of light, right? That's refraction. So Kiara, yeah, we got bending of light happen when light changes medium. So what is medium again? Ah, nice. So Isabella and Aslan both got it. It's different material that the light is traveling through. Alessandra, I think, has it as well. Good. So it's what matter light travels through. Okay, and a couple examples from Isabella. Air, light can travel through air, and light can travel through glass. Another one is water. Now, some I can't put. I can't put like brick, okay? Regular visible light doesn't go through brick, but it goes through air, glass, and water, okay? And we're going to mainly stick with these two. We're going to talk about air and glass today, and that'll lead to our next subject in just a moment. Yeah, exactly. So what the matter is what type of matter the light's going through. Just reading your comments here as we go. Good. All right. I need to erase. What really is happening is, to be honest, when light goes through an optically denser medium, it slows down and bends. We're going to draw that so you know what I'm talking about. When light goes through an optically, sorry that's so scientific, but I have to say it that way, an optically denser material So when light goes through an optically dense material, light slows down and its rays bend. And let's now draw a picture of that. Ooh, my writing's pretty bad here. Let me read that again in case you can't see it. When light goes through an optically denser material, the light slows down and its rays bend. I want to show you which way it bends. right now. So here we go. Let's say we got some water. And we got a ray coming in. Here's a ray of light. Ray. Let's say it's coming from the sun, all right? So here's your source of the light, sunshine. Well, what happens? Okay, so we're going to draw an imaginary line where that light hits a vertical line like this. What happens is when the ray gets in the water, it slows down and it bends towards that imaginary line like this. Okay, this one's coming in, so it's called the incident ray. I know I'm writing that small. Let me say it again. This one coming in, it's called coming into the water. It's called the incident ray. And the one going out is not so hard. It's called the refracted ray. And of course, we got air and we got water, don't we? Okay. We still working? Yeah, we're still working. This line here, and you might have this in other classes, it's called the normal line. It just means a line that's like perpendicular to the water, okay? At any rate, what happens is, here's the ray coming in, right? Is this angle. And then when it goes down in the water, it's lower. It's a lower angle to get to the normal line. So let's like this. Because it bends, right? It slows down and goes. And you've noticed this, I bet. How many of you have noticed this? Have any of you been in a pool or in a lake and you look down and your arms in the water and your legs look funny? Have you noticed they don't look the same as when when you pull them out of the water, they look normal. And they go down deep in the water, and sometimes if they're not right under you, they look kind of weird. Well, now you know why they look weird. The light is refracting when it goes into the water. So your hands and arms and stuff look like they're at funny angles. Because they are at funny angles. They're at different angles when we look down and see them, isn't it? Because of the bending of the light when it goes in the denser water. Cool stuff, huh? Okay, see if you got any questions before we go on to what I got right here. I know you can't see it, but I'm going to show it to you in just a second. Is it always bending at the same angle to the line? No. The short answer, Kiara, is no. It depends on two things. It depends on the ray coming in, and it depends on the material. So there's a formula you may get in 10th, 11th, or 12th grade, which is called the law of sines, sine, cosine, tangent. It's math I don't think you've had yet. And this, Kiara, this law needs the law of sines to help you figure this out. You can also have nothing at all happen. Check this out. If I send a ray of light directly down this line, the normal line, it doesn't refract at all. It goes straight through. So it depends, Kiara, on the angle I choose coming in and on the stuff I go into. If this was glass, it would bend a little differently. Kind of a long answer to a short question, I know, but that's the truth of it. Let's see, another one from Alessia. When you look at swimmers, they look behind from A to B than they actually are. I got to think about that. Yeah, okay, right. Yeah. Yeah, yeah. Because again, they're in the water, so you can't see all the parts of a swimmer when they're going by so easily because they're in different spots than they look from your point of view. Same with fish. If you're a fisher person and you try and fish and you even see a fish, the fish is not where you see it. Okay? It's actually when you look, you see the fish out here. If I'm looking, I'd see the fish here, but the fish is not there. The fish is here. You know what I'm saying? I know it's not an alpha symbol. Now it's a fish. Sorry. So if you look, a fish looks like it's over here, but it's actually closer to you and deeper. Isn't that weird? So if you're fishing, the fish are not where you think. They're closer and deeper because of that refraction of light. Okay, yeah? Okay, so let's start really with something concrete, or in this case, something glass, which I'm going to show you in just a moment. But that's how refraction works, and that's how it's going to work in the glass that I show you as well. So light's going to slow down, and it's going to bend. And whoever said rays really had it figured out. Okay, you ready? Here we go. There's what I want to show you. And this is called a lens. And we're going to use in our class symmetric lenses. The ones in your eyeglasses, if you wear glasses, are not symmetric, but this one really is. So it's a thin, I'm going to draw this shape. So this is a lens. Whoops, I just dropped it. So let's talk about lenses. We've got two types. And the first type is going to be called a converging lens. We're going to draw it in a minute here too. Converging lens. And it has another name based on the shape. Let's see if I hold that really close, if you can see the shape. So, well, hey folks, am I still there? It said I was offline, but now it's on again. Can you still hear me? I know my technology's not perfect here either. Are you guys still there? Can somebody say hello? Yes, we're here. Just so I know. Ah, thank you. Thank you. Aaron, Inessa, Michael, thank you. Okay, good. It's working. All right. Whew, thank goodness. I hate it when I crash. That really breaks my day. Thanks, everybody. Okay, it's lagging. Ah, I'm sorry. Okay, thanks, Allie. Okay, all right. Thanks, Tim. Okay, so let's get this shape. Let's just draw it. Okay, here we go. So what I'm saying is this shape here is what we're talking about. It's more or less this shape, okay? And if I got something that bows out, what's that called? If it bows out in math class. Okay, it's called a, yeah, good, Isabella, convex. So this is also called a convex lens. Okay, let's see why it's called converging lens. All right. What happens is I can take this lens and I can bring it close to the I can bring it close to the whiteboard, and I'm getting an image. I don't know if you can see that or not. And it's coming from, actually, I'm getting two images. I'm getting one from the window, and that's the one I want. All right, we're going to try this with the lights off, okay? Don't everybody get scared. Okay, I don't know if you can see that or not. So I'm going to go through here, and I'm trying to make an image. There you can see it, maybe pretty good. So there's an image back here. I'll put my finger on it, and it's going to get sharper. And right there, it's as sharp as it's going to get. And what that image is for me, it's of the window behind you, behind the computer. So what happens is I can make it blurry, or I can make it blurry, and if I hold it right at this spot, the image gets nice and sharp from the window. Okay, I'm going to draw that for you. So what's happening with the rays is, here's the window, all right? The window is out here. Okay, here come the rays of light. Let's make them all parallel because the window's, relatively speaking, far away. Oh man, my drawing's awful. So here come the rays of light. And let's just make 4 parallel lines. What happens is, here's where I held the whiteboard, and I get a spot here where all the rays come together, like this. And notice that they're bending just like the light that went in the water, right? That we talked about the fish. Well, if this is made of glass, and that's what it's made of, is glass, okay? So lenses, glass, they can be made of plastic or well, as well. So lens is glass or plastic. But all these lines, when they go through, are going to bend a little or a lot. And notice, Kiara, since you asked about it, the ones that are closer to the middle, they bend less. And all of them land at the same spot right here. And that's where I saw my little picture of the window at that spot. Okay. Convex is a math word which means bent outward or flexed outward. Okay, if you got like a muscle, okay, it's flexed out. Your muscles are convex. They flex outward. And that's what a convex lens is. The glass is out from either side, from the middle. Okay. From here to here, to get that, to find that special spot, let's mark that in red. We're going to mark that with the letter F, small f. And F, when I can find that spot from light that's far away, F is called the focal length. And it really is, it's a length or distance for light rays that are parallel to all focus on one spot. So it's where parallel light rays all join. Oh, I'm going to use a good word. Where parallel light rays all converge. Aha, that's why it's called a converging lens. So let's use that word. Now you know why it's called converging lens. Okay, so where parallel light rays all converge is the focal point. So the distance is called the focal length out to that point. So the distance for me was about, I don't know, maybe 10 centimeters to get to that. From the lens to the nice picture, I had about 10 centimeters. That was my focal length. And the spot where they join together is called the focal point, okay? But the distance out there that I marked here in F, that's the length of that thing, from the lens to where it lands. We're going to do that again. And if we're lucky and I get to see you, you're going to do that in person in a lab. Can you imagine a lab, like you actually doing some physics? I hope it happens next week, and then the following week for the B group. I hope so. Okay, so that's one of our two types of lenses. Let's see if you got any questions about that. So that's our converging lens, which is convex in shape, converging lens. Okay, so I'm going to try and hold that really close so you can see that it's not flat, but it kind of bows out a little bit on either side. Okay, all right. Okay, let's see if you got a question or two. Yeah, the opposite of convex. We'll find out what that is in just a second. Yeah, Kiara asked, will we use a formula or something to find out the focal point and length? Yes. So one way, Kiara, is you can find the focal length by doing what I did. You can see where the rays converge on a screen like this. So you can do it physically, or there's a formula you can do it, Kiara. We're going to do that also. And the third way is a diagram. So we're going to learn all three, and that's most of what this optics unit is about. So good that you ask about formulas. We will have one, yes. And Alessia asks, the focal point is basically a union point for all the light rays. Yes. Yes, it is. Okay, you ready for the other kind? I'm ready to blow my nose. Hold on. Okay. Here we go. The other type looks like this. I'm going to hold it up and kind of go back and forth with it in hopes you can see it. And I'm going to draw it too now so you can see it as well. So this is the second type. And instead of a converging lens, can you guess the name, somebody? Instead of a converging lens, it's a lens. Can you guess it? So what do you think? The shape has been guessed by Isabella. It's a concave shape. How do I remember concave? Because it's bent in, like there's a cave in there. Ah, right, concave. Think of like a little cave being in the sides. And it's called a hey, concaving. I like it, Devante. Not quite, but I like it. I like it. Okay, this is called, instead of converging, the opposite of converging is diverging. So this is called a diverging lens. So diverging lens looks like this in cross section, right? So that's that. That's that. Okay. I'm going to pull it out to you and show you again. So it's like this. Okay. So it's bent in both sides. So let's see what the light does. Ready? Yeah. So it's concave on both sides instead of convex. So it's diverging, right? A diverging lens. You can also say divergent if you've read it that way in a book. Okay. Here comes some rays. So here's like the window again or whatever. Okay. Oh, by the way, I'm going to do this here. Do this here with you. Okay, ready? Don't get scared. Lights are going off. Here we go. I'm going to pull that in and go back and forth. And you know what, gang? No matter where I put this thing, I get no image. I get no spot where I get the rays from the window focusing. So I'm not getting what's called an image at all with this sort of lens. You might say, well, what a crappy lens. Well, it's not crappy, but it does something different. it does something different. Here come the rays of light. I'll draw 4 again. 1, 2, 3, 4. Well, what do you suppose the light does? What do you suppose the light does when it goes through? How's it going to come out the other side? It's going to be different than the converging lens. What will the diverging lens make the rays do on the other side? Can you guess? In a way it does. Yeah, Devontae, it kind of expands or scatters is another way to say it. It does break the light up. It does bend it. It does bend it, Kiara. So here we go. Ready? Check this out. It bends it away like that. Whoa, so the light rays, well, the only word I can use is they diverge. To converge means to come together. Convergent. Divergent. Go apart. So the light rays diverge. Sometimes you're on a road and the road diverges into 2 roads, right? When you get a fork in the road, a gabelon, right? The road diverges. So rays can diverge as well. So I don't get a nice length, or do I? I do get a focal point and I get a focal length. And I'm not going to draw it on here, but I'm going to show you kind of what you do. What you do is you bring these guys backwards. Ready? Bump, 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 bump. Ready? Bump, 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 bump. Oh, the focal length ends up being back here. If I take these rays backwards on the other side, I get the focal point here, and the focal length is from here to the middle of the lens. So these diverging lenses also have uses. Hint, hint, a lot of you wear glasses that include diverging lenses. But that's a good place to stop for today. We're going to do more when I see you again. I'll let you know when I could do another live stream with you. Thank you for making it. Let's see if I got it doesn't magnify it necessarily, Leo. Not necessarily, it doesn't necessarily make the objects seem bigger. But I'll just say bye to all of you. So thank you for joining me. Good participation. Look forward to next time and maybe seeing some of you live next week. Have a good day.